Hello everyone, welcome to OVERMUGGED Sec 3 IT Physics revision lesson. Yep, so for today, I will be conducting the lesson. So I am Miss Felicia. Yep, so you can call me Miss or you can call me Teacher Felicia also can. So if you have any questions during today's lesson, you can feel free to ask me either through unmuting your microphone, or if you are shy, you can always type it in the chat. Yeah, so I'll keep a lookout for the Zoom chat. Yep. So for today's lesson, we will be doing on these three topics: scaled vector diagram, kinematics, and dynamics. So let's begin. So make sure you have a copy of today's notes. Yep, because I will need you to follow me and highlight. So whenever I highlight, you follow and highlight. Then whenever I write, you follow me and write it into. Okay. Okay, so for this for scaled vector diagram. So scaled vector diagram is actually a topic that you will actually see in the topic of physical quantities, yeah, or you will also see in the topic of dynamics. Yeah, so generally when you need to draw scaled vector diagrams, whenever object is at equilibrium meaning the object is stationary, then take note that the resultant force is 0. Because like, for example, if an object is stationary, means maybe you pull to the left 2 Newton and pull to the right 2 Newton. So it cancels off, it balances out. That's why resultant force is 0. So since there is no resultant force, so take note that you cannot draw the resultant line. That means when you draw using the triangle law or parallelogram law, you should not have this line. This one. Yeah, you should not have such line, okay? Cannot draw because there is no resultant. So there should not be resultant line. But instead, for all the arrows that you have drawn, the line should keep going in circles. So what do I mean by this? I will demo it to you at the bottom. Okay, then next is if the object is moving, that means got resultant force, right? So maybe the force is like greater towards like a certain direction. So that's why, yes, you can draw the resultant line, which is this line over here. You can draw it. Yep, then you will realize that, oh, there is a starting point and there is an ending point for you to link the resultant line. Okay, so right now I'm going to introduce to you the two methods to draw it. So for the first one over here, it will be the triangle law. So personally, I would prefer you all to draw the triangle law as compared to the parallelogram law. Because for triangle law, you actually need to draw only, you see, 3 lines. As compared to parallelogram law, you need to draw like 1, 2, 3, 4, 5. You need to draw 5 lines. So it's like the more lines you draw, the more likely you make mistake. Because if every line you just like make a mistake of 0.1 cm, then if you times 5, then the effect will be magnified. Yeah, so I will prefer you all to do triangle law because you draw less lines, you will make less mistake, and you can save more time too in exam. Okay, so what is the triangle law? Mainly is that you shift or rearrange the lines. So my method of trying to know like if my triangle law, like did I connect the lines correctly? My method will be so-called the monster walking method. Yeah, so you imagine that like maybe like, you know, in some computer game or something, you have like this like a monster character, yeah, that's in the game. Yeah, then you will be having the 2 paths over here for the monster to walk. And then you might be confused like, in this case, should my monster walk up or should he walk down? Then he'll be like, oh no, headache, do not know which path to walk. So triangle law is that you have to shift and rearrange the line so that this little monster here has a clear path to walk. Yeah, so what I will do is maybe like, I can shift this line to be over here. Yeah, so that means this time around, the monster just have to walk up, then walk down. So can you see? Walk up, then walk down. Yeah, then since the monster started from the left side, yeah, so your resultant line, your resultant arrow, it will be from the start to the end. That's why you draw with a solid line and then double arrowhead to represent resultant. So take note that whenever you are drawing, these are the checklists. So for your exam, please remember, okay, that whenever you draw finish, think of these 4 points to make sure that you have a complete answer. So number 1, you need to have a scale. Take note that scale must start from 1 cm. So don't write a scale of 2 cm is to something. Don't write a scale of like maybe like 10 Newton is to something. Can you always start off with 1 cm? Because this is like the most proper way to write. But of course, if your school teacher is lenient, they may accept you to write like in other formats. But take note that this is a preferred method, which is 1 cm is to something. Then next thing to take note, is that whenever you have a scale, make sure that it must be in multiples of 1, 2, and 5. Can you follow me and copy this down? It has to be in multiples of 1, 2, and 5. Write it in. So if you were to give me a scale of maybe 1 cm is to 3 Newton or 1 cm is to 7 Newton, then your teacher will actually minus 1 mark down for scale. So take note, okay, must have the correct scale. Okay, then next thing is that because this is a vector diagram, vector means that it has both magnitude and direction. Yeah, so make sure that in your answer, in your drawing, you must show me the magnitude. You need to write like how many Newton is this line. So take note, okay, for this arrow, you are not supposed to write how many cm. You are supposed to write like how many Newton instead. Okay, not cm. Cm is just for your own reference to know how long to draw. Labeling is in Newton. Next. Vector means it has both magnitude and direction. So you need to show me the arrowhead. So for those arrow that is from the question like this, you can either draw the arrowhead at the end as shown here, or if you want, you can draw it in the middle. Also can. Both are acceptable. But make sure that as long as it is from the question, you can only have one arrowhead. Yep. So either at the end or in the middle. Then for resultant, you definitely have to draw in the middle. Resultant cannot draw at the end. Then lastly is the angles. Yep. So if the question were to maybe like they say that this time round I have this object here, the angle is maybe like 30 degree. So if the question give you 30 degree, then make sure that the angle from the question, which is 30 degree, is shown in this diagram. So I will need to like indicate here, oh, this part here is 30 degree. Okay, so make sure that the angle from the question and your answer. So maybe the question is asking you, can you identify what's the direction of the resultant force? So if you need to write a final statement on the direction, then you need to make sure that that degree, like maybe your answer is like 90 degree, and then make sure that the 90 degree is shown in your diagram. So that's what I meant by the angle from the question and your answer. Yep, so that's all for this part. So make sure that you have copied down everything that I've shown here. Yep, then once you are done with labeling everything, then I'll move on. So before I move on, just to double check, anyone have any questions so far? Before I move on, any questions? Okay, so no questions, and I suppose that you are done copying, so I shall move down. Sometimes if so usually I'll give you a warning before I move on. If there's too much to copy and then you cannot finish copying in time, you can actually take a screenshot, or maybe you just take your phone and take a photo, okay, so that you won't miss anything. Okay, so moving on to the next part is the parallelogram law. So parallelogram law mainly is that you duplicate the line. So that means for the lines, you don't need to rearrange. You see, the lines, you just copy directly as per what the question has shown. So take note that if the line pointing to top right, your answer also has to point to the top right. You cannot change the direction of the arrow. Okay, so if they point bottom right, you should also remain as bottom right. So for parallelogram law, you duplicate the lines. Since these lines are not from the question, it is that you duplicate it out. That's why these lines over here, it should be dotted line. Then a resultant is as usual, it will be the solid line with double arrowhead. Okay, so next is same thing for parallelogram law. You also need to make sure that you have the checklist. You need to make sure that everything is in place. Okay, so now let's give it a try and practice, see whether can you get the answer and know how to use all these laws. Okay, so the first kind of question that is the I'm doing the how to say the slightly more difficult one, not the the very simple straightforward. That kind I think you all know. Okay, so for this kind of question is that when the question only give you the magnitude of one vector, then they ask you to go and solve for the magnitude of two other vectors. So it's a bit different from norm, right? Because normally they should give you two vectors. You go and find the third vector. But this time around, if they only give you one, then how? So since they only give you one, the method to do it is that you draw the one that is already given to you. Then the rest, right? Usually they will, if they never give you magnitude, they will at least give you the angle. Yeah, so you just measure according to the angle and let the line intersect. So what do I mean by this method? Let's take a look at this question here. So figure 1 below shows a photo frame of weight 50 Newton hung from a ceiling using 2 strings at an angle of 50 degrees and is at equilibrium. That means it's stationary. So hope you still remember, whenever objects are at equilibrium, as mentioned on the first page, is that the objects, you cannot draw the resultant line. Okay, you cannot draw the resultant line, and then the lines should keep going in circles. Okay, so let me come back to this question here. So that means later, right, you must make sure all the lines you join together, then the monster will just keep walking in circles. Like there is no start and there is no end. This is for object that is stationary. Okay, so by drawing a scaled vector diagram, find the magnitude of the tension in the, typo error, in each string. Okay, so how do you do it? So at the start, you should always have a scale, right? Okay, so first, let's have a scale first. Yep, so can someone suggest to me what is a possible scale for this question based on the amount of paper space that you have? So any suggestion on the scale? Hello, I'm asking a question. So Faith said 5.
1 cm is to 10 N.
1 cm is to 10 Newton, can also, but I am worried that your drawing might be a little bit too small if it's 10. So I would say Faith and Yana's answer will be better. You should do as 5 cm, because if you do 1 is to 10, right? 50 Newton is only 5 cm, which is like pretty small, right? If you look at your ruler, 5 cm. Yeah, so a better scale, it will be 1 is to, not is to 10, but 1 is to 5. Yeah, so let's write in the scale now. Yep, so can you follow me and write the scale in? Yep, so let's do 1 cm is to 5 Newton. So for this question, how do you go about doing it? So since they already given you the weight, so weight is definitely downwards, right? So using this scale, can you draw out for weight first? So weight is very easy. It's just a vertical line straight down. Can you start drawing it now with pencil and ruler, please? Yep, start drawing. Yeah, so you draw a vertical line downwards. So based on this scale, your line, it should be 10 cm. Should be done drawing a 10 cm line, right? Okay, so then next is, after you have drawn, okay, I will just do a sketch, okay, because as you can tell, I don't have space at the bottom. Okay, so after you are done drawing a 10 cm line, next is, I will use the triangular, because I told you that I want to save time and be more accurate. So what you can do next is, you draw based on the angle, because that's what I mentioned in the method. Yeah, after you draw the known one, you draw the other two accurate to its angle. So in this case, the angle shown here is 50 degrees. So I will measure 50 degrees, then you draw this line here. Okay, so that means you can draw a perpendicular line first, then you measure a line that is 50 degrees. Yep, then for the line, how long it is, we do not know. You just draw as long as you can. Yep, so just a quick recap on in math, I think you all learned before, right? Alternate angles. Yep, so now my dotted line is actually this part here. Okay, so that means in this case, can you see the Z shape? So that means if this angle is 50, this angle is also 50. So this is the angle that I'm drawing over here. Yep, so can you measure using your protractor now and draw it in pencil? So how long the line is, you do not know, you just draw it long. Then once you are done with the bottom line, can you do likewise for the line on top? Same thing, you measure 50 degrees, then you draw it as long as you can. Okay, so once you all are done drawing as per what I've shown here, can you all click the reaction button, the raise hand button to let me know? Once you are done, click the raise hand button. Okay, so approximately about half the class is completed. Okay, so I move on. For those who are slower, you quickly catch up, okay? Okay, so then now that you have drawn, so But for triangle law, we don't have this kind of like extra lines over here, right? So what you need to do will be, for the excess lines, you go and erase it. That's why you need to draw in pencil. Yep, so can you go and erase it now? Yep, then after you're done erasing it, remember to include the arrowheads. So right now, can you refer back to the checklist and make sure that you have everything included? Yep, so can you go and finish up the diagram now? So you erase it, then refer to the checklist and include everything in. Yep, do it now. Then after you have finished checking using the checklist, can you write down the final answer? So for the final answer, they are asking you to find the magnitude of the tension in each string. Yeah, so can you write down a final statement? Magnitude of tension in each string equals to how much? Then after you have completed this question, can you click the raise hand button to let me know? So once you are done, then I'll review the answer. In case any of you are using Chromebook, then you cannot click the raise hand button. You can actually type it in the chat to let me know that you are done. Like you can type the word done. Then I know that, okay, you have completed. Yep, so people, once you are done, click the raise hand button. For those of you who are fast, you can actually move on to do the next question. Yeah, there's one more drawing on the next page. Yep, so if you know how to do it, you go ahead and do it. So Joycelyn is asking, is it don't need to draw the arrows for the other two lines? Have to. That's why you must always follow the checklist. You must always draw the arrows. Yeah, so just now I was asking you all to use the checklist and then you check whether do you have everything. Because I don't want to spoon feed you the answer since you are nearing to exam. Yeah, so Joycelyn, you check using this checklist and make sure everything is inside, okay? Then once you are done, remember to click the raise hand button to let me know so that I can review the answer. So when done, raise hand. If you can't raise hand, type it in the chat to let me know. The rest of you, while waiting, can you start and do the next question? Insyra, I'm sorry, I don't quite know how to pronounce your name. And Insyra, for the person who just spoke, just type in the chat, are you asking for today's worksheet? Okay, that's good. Okay, I think I've been waiting for quite a while, but there are still quite some of you who haven't completed. Okay, then in that case, I think I shall review the answer soon. Are you done? If you're done, remember to click the raise hand button. Okay, so I think I will review the answer now because I do not want to delay the whole lesson pace. If not, I cannot finish the lesson on time. Okay, so let me show you all the answer now. Yep, so here's the answer for this question. Yep, so can you all check and see whether you all get the correct answer? So here is the range that the answers can be accepted. Yeah, so by right, you need to erase away the excess lines. Okay. Then you just check whether do you have everything. So come, everyone, let's check your answer together. Number one, do you have scale? By right should have because we did it together, right? Then number two, do you have the magnitude for every single line? These numbers, do you have all of them? Then next, do you have the arrowheads? So take note, it is single arrowhead, not double arrowhead. Because as mentioned, when object is in equilibrium, there is no resultant force. You go and look at the first page right at the top. Okay. So for the magnitude wise, do you need to round off? If you have exact answers, you should leave it to exact. Yeah. Okay, then next is the angle. So the question, did they show angle? Yes, right. The question showed 50 degree. So can you make sure that you have the 50 degree, two of them? But for this question, they never ask you for angle. So there is no need to label the angle for the answer. Done. So this will be the complete answer. Yeah, so if your answer is not within the range, that means your drawing might be a little bit off, not accurate, then you need to remeasure everything again. Okay, so for the second question, can you give it a try now? Then once you have completed the second question, can you click the raise hand button to let me know? Then I'll review the answer for the second question. Yeah, so once you're done with correction, do the second question. Then raise hand when you are done. Okay, maybe I just give a little bit of hint for the second question in case you are stuck. Yep, so for this question, again, because it's in equilibrium, you can use the method over here to help you. So make sure that you rearrange such that when the monster walk, there is a clear path for the monster to walk, such that the arrows will end up just keep going in circles. Okay? Yeah, so that's how you draw it. Then take note, okay, that you cannot draw resultant line. So everyone, can you all check, did you draw a double arrowhead? If you draw double arrowhead, your answer is wrong. Then after you are done drawing, can you just go and refer to the checklist again? Yeah, so this is the checklist. Can you check whether is everything in to make sure that you can have the complete answer? Yeah, and so that you can get like the full marks. Okay, I give 1 more minute. If you are not done, then I really need to move on already. If not, I cannot finish the lesson. By the way, I'm not sure whether if any of you didn't manage to finish the correction. So for those of you who didn't finish this question or didn't do the correction yet, maybe you would like to take a screenshot because I'm going to change the screen soon to the other answer. Yep, so if you want to screenshot, you screenshot it now. And the rest of you, are you all done? Once you're done, can you click the raise hand button? Okay, so I think I shall move on. Sorry, due to time constraint, I really need to move on because today need to finish 3 chapters in 2 hours, which is quite chiong. Yeah. Okay, so let's move on to the next question. Come, let's check your answer. Yeah, so here's the answer for the next question. Okay, so things to check. Can you follow me? Number 1, do you have the scale? Yep, so take note that your scale, it has to be in multiples of 1, 2, and 5. Is it in multiples 1, 2, and 5? If not, can you do your correction? You can have other scales, but as long as multiples of 1, 2, and 5 will do. Then next, it will be the magnitude. Do you have the Newton for every single line? If any of it missing, can you don't change your answer? Can you do as correction? So that next time you know when you revise, then at least you know that, this was the mistake that I did last time. Then next is the direction. Yep, so do you have all the arrowheads? As mentioned, should not have double arrowhead. Okay, because all these lines are from the question. Then next, it will be the angle. So the question and your answer both got angles, right? So the question, in this case, the question, they gave you 37 degree. Yeah, so make sure you put in the 37 degree and your final answer also 37. That's why you must have both from the question and the answer. Then these are the range of possible answers. So if your answers are inaccurate, that means your drawing is a bit off. Okay, so yeah, so if you need to do correction now, can you quickly do it? Then once you are done with the correction, can you click the raise hand button? Then I'll move on to the next chapter, kinematics. Then if you think that you really need a lot of time, maybe you are quite slow in doing scale vector diagram, then maybe you want to take a screenshot instead. Yep, then after you take a screenshot, then you just click the raise hand button. So once about majority of you, maybe more than half of you are done, then I'll move on already. So once you are done with the correction and can move on, raise hand. Okay, so sorry, I think I need to move on already. So if any of you still haven't finished your correction, can you take a screenshot now? Yep, then I'll move on. Okay, so moving on in 5 seconds. 5, 4, 3, 2, 1. Okay, moving on. Okay, so yep, next part. Okay, so kinematics. Yep, so for kinematics, I think you all know mainly there are three main sections. Number one is the calculation. So here is the collated list of all the formulas that you need to know. I take it that by now, because it's end of year exam, you should know what does AVUTS mean. So I'm not going to go through anymore. Yeah, so this is the first one on calculation. Second section will be on graph drawing. Third section, it will be the free fall. Okay, so let's go into graph drawing. For the calculation, later there will be questions at the back. We can give it a try later. Okay, so yep, over here for ticker tape timer. So does anyone not know what is ticker tape? Because if you totally don't know what's ticker tape, can you let me know now so that I can tell you like what is ticker tape? Anyone don't know? If not, I take it that all of you like know what's ticker tape, right? Okay, so for this question here is a very common question. Oh, okay. So ticker tape, right, is actually a strip of paper that is usually you tie to the object that you want to measure the speed, like in the past. Because in the past don't have digital method. So maybe like I have like maybe a toy car. They don't know like how fast is this toy car moving. So what I will do is to this toy car, I will attach a tape which is called ticker tape. Then it will be linked to a machine where they will like punch hole at regular frequency. So that means as the train or as a toy car move, they will keep punching hole on the paper. So from the paper, you can actually know that, oh, is it becoming faster or becoming slower by looking at the spacing of the gap? And that usually the punching hole, you can control the frequency of it punching hole. Yeah, so by knowing the frequency, you can know like, oh, what's the duration per dot? Then later you can use your ruler to measure the cm per dot. So with the cm and the duration, you can find the speed. So that's ticker tape. So for ticker tape timer, there is such a question on asking you the average acceleration. So for average acceleration, there is actually a fixed method to go about doing it. So I'm going to go through now. Okay, so let's read the question first. The diagram shows a strip of paper tape put under a vibrating arm by a trolley moving at constant acceleration. So it's speeding up. So then they say that the arm is vibrating regularly at a frequency of 40 hertz. What is the average acceleration of the trolley? Okay, so for ticker tape, how you read is, because can you see that when you first punch the dot is over here. Then as the car continue to travel forward, the next time when it punch, it will be somewhere behind, right? Can you tell? Because as the tape move, you will punch somewhere towards the end of the tape. So that's why for a ticker tape timer, the right side will be the start, while the left side is the end. Yep, so can you follow me and label the word start and end? Okay, so take note that you have to check the direction of motion, because if the tape get pulled to the left, your start and end will get swapped. Yeah, so you have to check the direction of motion. So this is where you start punch first, then you pull. So as you pull, this will be the last dot being punched. Okay, so next is they also tell you that there is a frequency of 40 hertz. So for this frequency, it actually tells you that they actually punch 40 dots in 1 second. Okay, so then now, how do you count how many dots? So the best method is you always count the number of gaps instead of number of dots. Because if you count as number of dots, we always take the first dot as 0. So there's 0, 1, 2, 3, 4, 5 dots. Yeah, so best is you count the gaps. Yeah, so if it's one gap, that's like 1 dot, 2, 3, 4, 5. So this is 5 dots. Yeah, because if you count by the number of dots, it's like, how to say, like usually, you know, when we count object, like if I give you like how many apple on the table or how many pear on the table, we always count as 1 apple, 2 apple, 3 apple, right? We always start from 1. That's why for counting wise, we rarely start from 0. So there tend to be a careless mistake if you count the dots. So best is you count the number of gaps. So if got 5 gaps, it's just 5 dots. So in this case, because they are asking for acceleration, based on the formula above, in the same page here, what is the formula for acceleration? Which formula? First, second, third, fourth, or fifth formula? Based on the list of formula on top. Which formula is it? Fifth, not the first formula though. First formula is average speed, right? Yep, thanks Risha and Desiree. Yep, it's the second formula, okay? It's the A equals to V minus U over T. Yep, so then now we need to go and find out the V, U, and T so that we can get the acceleration. Yeah, because they ask you what is the average acceleration. Okay, so in this case, since you start on the left side, we will say that left side, it is like the initial, Then the behind part is the n, right? So n is after, so this is the final velocity. Okay, so first, can you go and find out what is the initial speed? So for the speed formula, which you all learned before in primary school, speed is actually distance over time, correct? Yep, so for the first section here, the distance is 5 cm, but take note, okay, always check if they are in the SI unit or not. So in this case, 5 cm is in the incorrect unit, so change to SI unit. Are you all copying? Make sure you follow and copy it down. Then divided by time. So in this case, for this section of 0.05 meter, how many dots are there? There are 2 dots. So you go and calculate, 40 dots is 1 second. So if it's 20 dots, sorry, if it's 2 dots, then it's how many seconds? Yep, so you go and calculate how many seconds is it for 2 dots? This will be your denominator. Yep, then can you solve out what's the answer for the initial speed? And that's your value for u. Okay, then once you are done for this, you move on to V also. Okay, so for Joycelyn is asking how to know if it's 40 dots. It's because of this phrasing here. They say it's 40 hertz. So frequency is like, example, how frequent do you visit McDonald's? Maybe I say that I visit like McDonald's 9 times a week. That's called frequency, right? Okay, that's very unhealthy. Yeah, but if you say about frequency, it's usually based on how many times in a unit time. So for physics, a unit time is 1 second. So that's why it's 40 times in 1 second to know that it's 40 dots. Okay. Okay, then once you are done with U, can you do likewise for the final speed also? Same thing, distance over time. So this time around, how many dots? It is only 2 dots, right? Correct, because there's 2 gaps. Yep, so you put this duration as the denominator also. Yep, then can you go and calculate out? Then after you calculate, can you sub it back into this original formula of A equals to V minus U over T? Oh yeah, and by the way, just to let you know that for the T, right, how do you calculate the time? Okay, so this is the most tricky part, which a lot of students got it wrong. How to know what is the time? You always base on it because this is average. Average usually, average usually you take like the center, right, to find the average. Listen up, when you are finding average, you always take the center. So that means for this section, the center is over here. For this section, the center is over here. So now you count from the center to the center, got how many gaps? So in this case, there is 1, 2, 3 gaps. Can you see? From the center to the center, there are 3 gaps. So for the time over here, you should sub in terms of 3 dots duration. So 3 dots is how many seconds? That will be the denominator. So this is the very important method that you need to remember. Whenever they ask for average acceleration, this is how you solve it. It's like a standard template, standard way of solving it. Yeah, so whenever you see average acceleration, just remember to use this method. Okay? Yep, so then once you are done calculating for this question, once you got a final answer, can you click the raise hand button? Then I'll review the answer. For those of you who are fast, sorry, I have to wait because I think this class is very big. Then yeah, everyone is like, different like levels in physics. Like some of you are very good, some of you are like weaker. That's why, yeah, let's wait a little while. Okay, so you're asking, is it initial velocity minus final velocity, or is it the other way around? So for the formula over here is V minus U over T. V, you have to remember from the notes, it is final. U is initial. So it's final minus initial. So all this you shouldn't be asking me, right? Actually, must study the notes more thoroughly. All these are like standard textbook content, but it's okay to ask, like just saying that, like I think you need to study a little bit more, yeah, because these are basic concepts. Okay, so since slightly more than half of the class has completed, so I shall review the answer now. Okay, so the correct answer will be this, negative 8.0 meter per second square. Did the rest of you manage to get the correct answer also? Yep, so as shown in my working just now, yeah, as long as you sub in carefully, it should be correct. Yep, so 2 dots. And over here for the time here is 3 dots. Then V minus U over T, final minus initial. Done. Yep, so if you got it wrong, can you quickly do your correction? Yeah, it is okay to not put 0.0. It's just that because usually when you go for exam, worksheet now can be 0.0, but exam usually teacher will make sure that you must have in the correct SF, right? If wrong, they will mark down, right? So since the question is giving like in like 2 SF, usually our final answer we don't write in 1 SF. Yeah, that's why we should write as 2 SF. Then if you write as cm per second, can. Cm per second is okay. Yeah. Done. Okay, so I shall move on. So should be done with correction by now, I believe. So if you are not done, maybe you want to take a screenshot. I'm moving on in 5 seconds, okay? Ready? 5, 4, 3, 2, 1. Okay, moving on. Yes, Yana? Oh, sorry, I just saw your message. You're asking, wait, how do you know how many dots are V? Oh, because based on the drawing just now, wait, let me just shift this. Okay, because based on this, for the V section, as you can tell, like you can only measure these two sections, right? Because only these two sections got the cm. Yeah, so that's why for the final speed, you have to use the behind section that is like given, or you just use what is given. That's why in this case, for the dots I mentioned, we always count the number of gaps. So in this case, for this part here, how many gaps are there? There are total 2 gaps. Can you see? 1, 2, 2 gaps. That's why you count as 2 dots. Then Rachel, you can write in 3 SF. But usually for this question, maximum they only show you 2 SF, like 2.040. You write 3 SF. If your teacher is strict with SF, you will get marked down because you are not writing in the correct SF. Unless your teacher say everything 3 SF, then it's okay. Okay, so let's move on to the next part. Okay, so next part is graph drawing. Need to know how to convert from the different types of graph to each other. So for displacement time graph, whenever you look at the gradient of a displacement time graph, it will give you the velocity. When you look at the velocity time graph, the gradient will tell you the acceleration. So acceleration time graph, don't go and find gradient anymore because there isn't any arrow. So acceleration time graph, usually you just read according to what it is. Then next is acceleration time graph. If you go and calculate the area under graph, it gives you the velocity. Then velocity time graph, you go and read the area under graph, it will give you the displacement. Okay, so now I'm going to teach you how to interpret the different graphs. So this is the main legend. As long as you follow this legend, right, you should know how to do for all of them. Okay, so let's take a look at the first one over here. So first is you have to check the gradient because in a displacement time graph, as mentioned here, displacement time graph, the gradient tells you the velocity. Yeah, so that's why for the gradient, if it is a positive gradient, it means that it has velocity, right? That means it's moving and it's moving in the forward direction. Meaning, right, like for example, if this is a start point, this is the end point. Yep, so if I have a positive displacement, it means that my object is moving forward. If it's a negative gradient, it will be this way, like it's moving in the reverse direction. Okay, then next is, do you know if the object is it moving on the right side here, or is the object on the left side? So is it like past the start point already, or is it before start point? Maybe you reverse from the starting point, right? Yeah, so to know which side you are at, you have to check whether is it above the x-axis or below the x-axis in a displacement time graph. Yeah, so that means if your arrow is above the x-axis and then it is positive gradient, that means your arrow will be like that. Sorry, like let me erase this first. That means it will be like that. Yeah, because above x-axis means you're at the right side, because right side is the positive side, because it is further and further away from the start point and nearer to the end point. So if your graph is above the x-axis and has a positive gradient, the object is moving in this direction and is at this position here. If your object is above the x-axis but has a negative gradient, that means it is still on the right side because it's at the positive side, but it is reversing. So that means it's like that. So it's still on the right side, but it's reversing. If your graph is below the x-axis, like below the x-axis, but then got positive gradient, that means it's at the negative side. That means it is before the start point. And then it's moving forward, so it will be like that. Then lastly, it will be if you are having a graph below x-axis and negative gradient. So this means that it's at the negative side, that means it's on the left side, and then moving reverse. So that means it's moving opposite direction, further and further from the endpoint. Okay? Yeah, so need to know how to interpret the direction of the car and the position of the car based on the gradient and whether is it above or below the x-axis. Can understand? Need me to repeat? Can follow, right? Okay, so let's take a look at each of the graph. Inside the explanation, I'll write down for you. They're like whether like are they on the like where are they, like are they on the positive side or negative side? Yeah, it will be written inside lah. So let's take a look at each of the examples. Okay, sure, I'll repeat for Ayana. Okay, so you follow the color code. So if I were to say that the car is okay, if the graph has a positive gradient, you know math positive gradient is like that, right? Like upward sloping line. So if you have a positive gradient and then the graph is like that, you see, above the x-axis. So if it's positive gradient and above x-axis, that means the object is moving forward and still at the positive side. So if you base on the start point, if you are nearer to the end point, we will say that it is positive. If you are before the start line, that means like, you know, a displacement of -5, that means it's like even further away from the end point, right? So that's why if displacement is -5, that means displacement is like below the x-axis, like over here. That means it is further from the start point on the left side. So now, looking at the pink color arrow, positive gradient and above the x-axis means that it's moving forward. So moving forward means it should go towards the end point and still at the positive side. That means it's on the right side. Okay, then next example, the blue arrow. For the blue arrow, this kind, it will be negative gradient, but still above the x-axis. So that means like your graph for the blue arrow, it should be like that lah. So negative gradient, but above x-axis. That means if your graph, you are at a displacement of 0. You know that at the start point, your displacement is 0, right? Yeah, so with a displacement of 0 when you're at the start point, but you see, he is at a distance very far away from displacement, but going towards start point. That's why you see the blue color arrow is from a place that is very far away from the start point, but he's going towards back to the starting point of displacement 0. So this is how you represent for this blue color arrow. Next one, the yellow color arrow, which is positive gradient, but below x-axis. So for the yellow color one, I would say the graph will be below the x-axis, but positive gradient. Yeah, so in this case, you realize that your displacement is from a very like negative value, maybe like -50, then it goes towards 0. That means you are from very far away, you are going back to the start point. Yeah, so that's why positive gradient and below x-axis, it will be this yellow arrow. Then lastly, it will be the green color arrow, which is negative gradient and below x-axis. So such graph, it will be something like that. Yeah, so that means you are from the start point, and then it's negative gradient, right? You know, math, positive, negative gradient. So negative gradient, it means that you are moving further and further away from the start point. Because start point is displacement 0. At the end, maybe your displacement is like -30. That's why you see, it's from the start point, you go further and further away. Yeah, so this is the guideline to help you locate the direction of the object as well as the position of the object. So I hope Ayana can better understand, right? Okay. Anyways, if you're still a bit lost, no worries. We are going through in detail one by one for the examples now. So I'll repeat again. Yeah. Okay, so take note that so right now we are going to do graph drawing. So take note that if it's a sentence writing, you know, kinematics, they will ask you like, you know, describe the motion of the vehicle. So when they ask you to write, remember, don't write the word rate of change of. Rate of change of is a word they use in math. Okay, so in science, in physics, when you want to talk about the gradient, don't write rate of change of displacement. You directly tell me, what's the gradient of displacement time graph? The gradient is velocity. Directly tell me, oh, the velocity here, gradient is 0, right? That means the velocity is 0. You follow me and write it down. So for this graph, gradient is 0. That's why velocity is 0. So can you see over here? The object is at rest. Okay, so now can you tell me if we were to draw out the graph for the VT graph, how do you draw it? Any idea? So let's draw in now. Okay, so maybe the first graph you label properly, then the next few graph, maybe the axis we can shortcut a bit. Okay. Yep, so let's label it. So it will be velocity slash the unit. Then x-axis will be time slash the unit. Yep, very good. Yep, thank you, Faith. Yeah, so the correct answer will be, it is just a horizontal line, it's a zero line because zero velocity. So you draw a graph that is like at the bottom. Maybe let me do in another color because like not obvious. Yep, so this will be your answer. Okay. Okay, so then moving on to the second one. Okay, so the second one onwards, I think I'll shortcut a little bit for the axis. If not, a bit cannot draw finish all the graph. Okay, so for the next one over here, let's interpret the graph again using the gradient. So for the gradient, this time around, it is constant, right? And what does the gradient of a displacement time graph tell you? Gradient of displacement time graph is velocity, right? Yeah, or you can use letter V. So in this case, if gradient is constant, means V is constant. So if you have a VT graph, constant. So how to have a constant velocity? It will be horizontal line. Can you see the velocity is constant at this value? Then next, you check, is it above or below x-axis? This is above x-axis. So if it's above x-axis, it will be at the positive side. That's why you see, I wrote over here for you, nice, at the positive side. Then next is the gradient. Is it positive or negative gradient? It is positive gradient. That means moving forward. So I've also written nice for you already. Okay, so no worries, everything I've written out nice for you. Okay, so I shall move on. You all should be done drawing the graph by now. If you need screenshot, you screenshot. If not, I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, then for the next graph over here, same thing. Let's draw the VT graph. Okay, so for this VT graph, same thing, need to interpret what happened to the gradient to know what happened to the speed. Yep, so in this case, the gradient, which is the velocity, is increasing, right? Can you tell? It became steeper. So for the gradient of a displacement time graph, it gives you the velocity. So for the velocity, it will increase. So that's why you see the explanation here is increasing velocity. So V increases, so that's why you draw an arrow, go up. Then you see the V increase from 0 to a bigger value. Okay, then next is that same thing, you also check based on the legend above, always follow the legend. So first you check, is it positive or negative gradient? This one is upward line. Upward is positive gradient. So positive gradient means it is moving in the forward direction. So there, it is moving forward. Next, you check, is it above or below x-axis? So for this graph, it is above the x-axis. That means it's still on the right side of the start line. That's why I wrote over here, that is on the positive side. Okay, then moving down, next one over here is the gradient again. So gradient this time around, can you tell it become more and more gentle? That means gradient decreases. This means that the speed decreases. So now same thing, we draw the VT graph. The VT graph will decrease. Yep, so this time around you draw it, come down. Can you see that the speed is from a very big value, it became 0. For Rachel, in a displacement time graph, you can't tell the acceleration. Because if you look at this part over here, a displacement time graph, at most, you check the gradient, can only tell you velocity. Displacement can't jump to acceleration. It's a bit too far. You can't derive the information on acceleration. Yeah, you can only tell about the information on speed. Okay, so then that's all. Okay, so then same thing again, you just same thing, you just follow the legend above. Yep, so this time around, it is the first part, it is positive or negative gradient. It is positive, right? Because it's going up. So based on that, positive gradient means it's moving forward. So that's why I've written down over here also that it is moving forward. Then next is it above or below? The answer is above x-axis, right? So that means it will be at the positive side. Yep, so at the positive side. Okay, so the next page, it is similar also. I want you all to now give it a try. Since I already demoed to you 4 examples, it's your turn now. Can you finish up the next page, the VT graph? There's 2 pages actually. Yep, so can you finish up the next 2 pages of the VT graph now? If anyone have any questions, meanwhile, you can also ask me now since I'm giving you all time to do your work. Yeah, so people finish up the next 2 pages, finish up all the BT graph. You can use the explanation column to help you to derive the answer. So overall, just to give you a hint, as long as it's the positive side, that means as long as it's moving forward, then it will be like positive velocity. Because you reverse, then it's negative velocity. Okay, so right now I will be appointing you all to help me to draw it on the screen. If I were to pick you to draw on the screen and then somehow your device unable to help you to draw on the screen, you let me know, then I will then reassign someone else. Okay, so it's okay to get it wrong. Just give it a try lah. Okay, so I'll just follow the Zoom chat the list lah. Okay, so maybe I start from the bottom instead. Okay, so I follow your Zoom naming. So yep, you draw it on the screen for me. Yep, so once you see your name, can you do that question first? You solve it on your paper first. Once you have the answer, you present it on the screen. Then after you present already, you then continue to finish up the rest of the question. Yeah, so you present your answer first. Yep, so can ZL, Z, XT, Joycelyn, Shannon, Ray-En, and Risha present your answer on the screen? Thank you. If any of you can't draw on the screen, you let me know. Okay, then for Shannon, I will replace with can Renee present your answer for this one here? Thank you. Good. Mainly the shape lah. Is even if you never label V and T is okay. I just want to know whether like concept wise you can get it or not. Yeah. Oh, this one is not correct. It should be like that instead. Okay, so this one I will explain how come the answer is like that. Because for this case, if you check the gradient over here is increasing and then it is negative gradient, right? Because in math, upward is positive, horizontal is 0, downward is negative. So it is increasing, but then it's negative. Increasing and negative. Yep, so that's why you must draw in the negative region. Okay? Yeah, because if not, you can also follow the legend on top. So I did mention that over here, let me just go through. Because negative gradient, it means it's reversing. Reversing means your speed, it should be negative value. Yep, because you know, negative velocity, it is reversing. Okay, so this is then the answer. Yep, then the gradient is increasing. That means the speed is increasing. Also, the speed increases from at rest 0 to a bigger value. XT also cannot draw. Okay, then in that case, let me see. Can I get Renan to help me to draw for the third one? Thank you. Okay, let me continue check on the rest of your answers. So, the fourth one correct. The fifth one also correct. Oops. Next one. Correct. The other one, yes, correct, very good. Then the rest of you, can you all check your answer and see if it's correct after you are done drawing? I would prefer that you give it a try and draw first before you look at the screen for the answer. Can Renan draw on the screen? Then take note that there's also another page behind, okay? So make sure you finish the next page too. Oh, okay, can. So for this one over here, right, the explanation. So wait, let me just move this far away. Okay, so for this one over here, if you look at the gradient, okay, let me write it down on the left side. Okay, so for this case, for the gradient, first is the gradient is actually becoming less and less steep. That means it's becoming more gentle. Becoming more gentle means decreasing gradient, correct? Then next is you check the gradient. It is this direction, right? This is negative. So gradient means the velocity. That means it's saying that the velocity is decreasing and it is a negative velocity. That's why you should draw it in the negative region, and then it's decreasing. Decreasing means your speed maybe from a super fast, then you become at rest. You become like you come to a stop. That is called decreasing speed, right? That's why you see the graph must try to reach the x-axis to show that your v becomes 0, like you coming to a stop. So just to check, the person whose name is underscore, you understand what's going on now? Can I? Okay, that's good. If can, maybe you change to your name. Can a bit weird to call you underscore. Yeah. So just to check, Renan, are you able to draw on the screen? Is Renan around? If not, I'll just appoint someone else. Okay, I think maybe I think to save time, because I need to move on, I'll just review the answer for the third one. Yeah, so for the third one, it will be like that. Yeah, so this will be the answer for the third one. Anyone need me to explain any of the answers here? Second graph is this one, is it? So like you don't understand my explanation just now, is it? Okay, then for Rachel's question on this and this, why are the answers the same? It's because for both of them, the gradient, as in the shape is the same. You see, if I go and highlight it, isn't it same shape? So same shape, then the answer is the same. Because in to find out the velocity, based on here, velocity is always based on the gradient. So you always check the gradient to know how is it like. Yeah, so above and below x-axis is just the location of the object. It's not related to velocity. So to know the velocity is only the gradient. Since the gradient is the same, the answer will be the same for velocity. So Rachel, okay, right? Okay, so for Joycelyn, let me repeat again. So for this diagram here is because the gradient is increasing, gradient is getting steeper. That's why gradient increases. And based on math, downward sloping line is a negative gradient. That's why the speed is increasing and it is negative. That's why you draw it with a v value. Do you realize it is a negative v? Because over here, negative velocity. Yep, so that's why you draw in the negative region, and then the speed is increasing. So from a speed of at rest 0 to a huge number, aren't you increasing your speed from at rest to become very fast? Okay, so Lily is asking about why are graph 2 and 3 increasing constantly in a straight line? There's no way that you can draw curve line in the velocity time graph column, because from a displacement time graph, you can only tell if the speed is it increasing or decreasing. So I can only draw the VET graph, whether the line go up or go down only. Yeah, so it will definitely be straight line. Because if it's a curved line, that is acceleration. So based on what we have went through over here, you are not able to tell acceleration from a displacement time graph. From a displacement time graph, at max, using the gradient, you can only derive info on the velocity. You won't know the information about acceleration. Yeah, so that's why we only know the velocity go up or go down. So that's why the lines are just going up and going down. We can't draw curved line. Can understand? Any other questions before I move on? And anyways, I'm going to move on. If you are not done, can you take a screenshot now? I'm moving on in a few seconds. Yeah, so for now, we just assume that it's constant acceleration because there's no information given on acceleration. And you can't derive any information on acceleration too. Yep, so we have to assume constant. Okay, so moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for the next page over here, let me get some of y'all to present the answer to. Just now, where did I stop at? Okay, so can I get let me see. Can I get Oscar to present this answer, Lin Xuan to present this answer, and Lily to present this answer? Thank you. I just need the shape. Don't need to label V and T, it's okay. Just need the shape. Then don't need draw very nice. Even your line crooked is okay. Concept correct will do. This one not correct. The drawing should be like that instead. Okay, so let me explain for this diagram here. So same thing, always check the gradient. The gradient this time around is constant, right? Because at the start and at the end is the same steepness. So it's constant. Then how's the gradient here? So based on math, upward is positive, downward is negative. This is positive gradient. That's why you must make sure that gradient, which tell you the velocity is a constant and positive gradient. That's why you see the VT graph is a positive velocity and it is constant. So this is the answer. For the next one over here, for Lin Xuan answer, not correct also. So the correct answer should be this instead. Because for this case here, if you look at the gradient again, for the gradient, this is actually decreasing gradient, right? Can you tell it became more and more gentle until it becomes 0, decreasing? And then this upward. Upward is positive gradient. Yep, so it's positive. And gradient of a displacement time graph tells you the velocity. So that means my velocity is positive, decreasing. Then it must be a positive value. And it's decreasing to 0. So this is then the answer. Yep, Lily's answer is good. Correct. Done. Okay, so I'm moving on in 3 seconds. Any questions? If not, I'm moving on. If you need, you quickly note down your corrections. If not, you can take a screenshot. Moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so the next part over here is velocity time graph. So as mentioned, similar to the previous section, always refer to the legend. Because the legend will tell you how to interpret it. So for velocity time graph, different already. Just now, like positive and negative, yeah, it refers to different thing already. So for velocity time graph, if it's positive gradient, that means the line going up, it means it is speeding up, it is accelerating. If the graph is coming down, negative gradient, then it means it is slowing down. Then whether is it above or below x-axis, yeah, it will tell you which direction is it moving. Because if it's above the x-axis, that means your speed is positive, right? Positive means you are driving forward. That's why it's moving forward. But if your line is below the x-axis, that means you are reversing. Because negative velocity means that, you're moving backwards, reversing. Then same thing also for sentence writing. Don't write the word rate of change off. You write as acceleration instead, because rate of change off is the gradient. Gradient of a VT graph tells you the acceleration. So for this graph over here, how to interpret? So for the first one here, same thing, you look at the gradient. So for the gradient of, wait, let me, maybe I do it this way. Then I can see everything, including the legend. Okay, so for this graph over here, the gradient obviously is 0. So if your gradient is 0, that means your acceleration is 0. So that's why when you draw the acceleration time graph, you just draw it to be at 0. Come, let's draw it in. Yep, then you just draw a line that's on the axis. Okay, then let's label it properly. So this acceleration slash the SI unit, which is meter per second. Then time, it will be in seconds. Yep, then next part over here, this one is looking at the gradient again. So the gradient at the start versus at the end, it is the same steepness, right? So that means gradient is constant. Okay, then if gradient is constant, that means gradient of a VT graph tell you the acceleration. the acceleration is constant. No? So that's why in this case, if you were to draw a graph, yep, you should draw a line that is constant. Yep, so it will be horizontal like that. Yep, so in this case, since it's a positive gradient, that's why it's accelerating, right? So you see from speed 0, it became very fast. So it's accelerating, that's why it's positive acceleration. And this graph is above the x-axis. Above the x-axis means it is moving forward as indicated here. Okay, so for the next page, again, it is graph drawing. This time around, to speed up the lesson time, I won't be, oh wait, sorry. Are you all done drawing? Should be done by now, right? If you're not done, can you try to like screenshot it soon? Because I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for the next page over here, for the acceleration time graph column, I'll leave it to you to practice on your own, see whether you know how to convert the graph, since I already demoed 2 of them for you. I'll just explain what the graph means, okay? Then towards the end of the lesson, I'll provide the answer key for this whole worksheet. Then you can check your answer, whether your graph conversion is correct or not. Okay, so for a VT graph over here, so same thing, always look at the gradient, because gradient of VT graph tell you the acceleration. So in this case, the gradient is increasing, right? Yep, and then it is positive. So based on the legend over here, whenever you have a positive gradient, it means that you are having acceleration. Yeah, so that means this graph is trying to tell you that it is actually having an increasing acceleration. Okay, how this one you just copy down. Increasing, positive means acceleration. That's why it's over here, the increasing acceleration. Next one, for this graph, same thing, you look at the gradient. The gradient is decreasing, right? Because it's becoming 0. Then it is upward sloping. As long as upward in math, upward is always positive. Yep, so that's why in this case, same thing, looking at the legend, positive gradient means acceleration. That means now what happened to the acceleration? It is a decreasing acceleration. Can you see it over here? So the answer is decreasing acceleration. Okay, then next over here, the next one, it will be the gradient again. The gradient, it is constant, right? Because at the start and at the end, it is the same steepness. So it's constant. And then now it's a downward sloping. Downward is negative. Then looking at the legend, you can look at the previous page. Positive gradient is acceleration. Negative gradient will be deceleration. So this is actually trying to tell you that what happened to your acceleration time graph? It should be a constant deceleration. Can you see that you are slowing down, you are decelerating to come to a stop? Okay, so I'm moving on. Have you all done copying down? I'm going to move on in 5 seconds. If you're not done, you take a screenshot. 5, 4, 3, 2, 1. Moving on. Any questions so far? Yes, Ian? Will Ian want to unmute the mic instead? Because like we are all waiting for you to type. Oh, why is the graph for the second one? You mean like what is the graph for the second one? Or like you don't understand why my explanation is like that for the second graph? Moving up. Moving up when is, I don't understand your question. Moving, yes, I will be giving you all the answers at the end of the lesson. That's why I'm saying that this column you can try it on your own at home at your own time. Yeah, I'll provide the answer at the end of the lesson. Oh, sorry, Ian, I don't quite understand what you are saying. Maybe I move on first because I don't receive any clarification from you. Then I can't answer you. Okay, so the next part over here, same thing. Let's take a look at the gradient. So for the gradient of this graph, this one is increasing gradient, right? Can you see it became steeper? And then this is negative, right? Because for math, downward is negative. So whenever it's negative, looking at the legend on the previous page over here, the negative gradient means deceleration. That's why in this case, it will be increasing deceleration. Yep, so that's why it will be increasing deceleration. Can you see? So that means like the person is stepping on the brake at the start. He stepped very gently, but towards the back, he pressed the brake super hard. That's why it's called increasing deceleration. The next graph over here, follow and copy it down, please. Next graph, the gradient became gentler. So that means the gradient decreases and also downward sloping line. Downward sloping means negative. Negative means deceleration. So that's why you see the answer here is decreasing deceleration. So that means your graph, you should be drawing a deceleration time graph. That means when you draw over here, you should draw like below the x-axis because it's deceleration. So to answer Auyana's question, when will the acceleration graph be below x-axis? Is when you are having deceleration, because negative acceleration is equals to deceleration. Okay, then next one over here for the gradient. This time around the gradient, it will be horizontal line is 0, right? Yep. Then this time around it is just 0, then just 0 acceleration. That's it. Okay, good that Ian managed to figure out. So for Rachel's question, you're saying for the first graph, the acceleration will be a straight line downwards, right? Yeah, correct. Yeah, so it will be from the origin, you go down. So that means it's below the x-axis. Okay, so I shall move on. You should be done noting down by now, right? I'm moving on in 5 seconds. If you're not done, you take a screenshot. 5, 4, 3, 2, 1. Okay, moving on. Okay, so for the last one over here, same thing, you take a look at the gradient. So for the gradient, this is actually constant gradient, right? Because at the start and at the end, it is the same steepness. So that's why this is constant. Then since it's a downward sloping line, as mentioned, downward is negative. So this is negative. As long as you see that this is negative, but be careful because it's below the x-axis. So if you were to look at the number, right, this value here is 0, while this value over here is like maybe, example, I just randomly put a number, maybe negative something, negative 20. So if your speed, take note, math versus physics is different. For math versus physics, math usually we will say that 0 is bigger than negative 20, correct? As compared to physics, in this case, it will be opposite. 0 versus negative 20, we will say negative 20 is bigger because, listen up, it's important. Because for negative, it just means the direction. So it's just trying to tell me that, oh, I'm actually reversing. And what am I reversing? I'm reversing at a magnitude of 20. That means I am moving, right? So for this number over here, this object is actually moving. As compared to 0, 0 is at rest. So when you are reversing, like, when you're reversing at the speed of 20, isn't that at a faster speed than at rest? So that's why in physics, negative 20 is bigger. Because for physics, the negative doesn't affect the value. Negative only tell you the direction. So when you look at it, we should say that the speed is 20 and then it is reversing. So speed of 20 is bigger than the speed of 0. So in this case, speed of negative 20 is at a higher speed. That's why in this case, if you are changing from speed 0 to 20, that means at rest, you start to reverse. That means you are speeding up, right? Because from at rest, you start to move faster and faster and faster. That's why you are accelerating, not decelerating. So take note that although here is negative, but because it is below the x-axis, so below x-axis is like, double negative because this is negative. And then below x-axis is another like, negative. Negative, it became like positive over here. Yeah, so if you don't know this double negative thing, it's okay because this is confusing. You just directly read the value. 0 become negative 20, that is speeding up. Because from at rest, now you are moving. So you are moving faster now. That's why it's an acceleration, not deceleration. Yeah, so that's why for the last graph over here, when you draw, you should draw the graph to be above the x-axis. Can understand? Anyone need me to repeat again? Can follow, right? Then I move on. So I hope you are done noting down everything. I'm moving on in 5 seconds. If you're not done, you take a screenshot. 5, 4, 3, 2, 1. Okay, moving on. So for acceleration, how to tell the direction? You mean acceleration time graph. So in this VT graph, you can tell the direction because positive, go back to the legend again, positive gradient means that above the x-axis means you're moving forward, so you can tell the direction. Below x-axis means you are reversing. So for VT graph, you can tell the direction. But for AT graph, acceleration time graph, over here, you can't tell the direction already. So acceleration time graph only tell you the velocity, because based on what I went through on the start of the graph, that acceleration time graph, if you look at the area under graph, it gives you the velocity. Yeah, so that's why in this case, you can only know the velocity. You can't tell which direction it is moving. Okay, so for acceleration time graph, as shown just now, take note, acceleration time graph, I already reminded you all just now, don't need to find the gradient anymore. Do you see there isn't an arrow that says acceleration time graph, arrow gradient? So don't look at the gradient. You directly interpret the graph by reading it. So this means that, oh, positive acceleration means, yeah, it is accelerating. Oh, that means the speed increase. So as long as you are above the x-axis, that means it is a positive acceleration value, means it is accelerating. Then if it is negative acceleration value, so remember, negative acceleration is deceleration. That's why in this case, below the x-axis is deceleration. Yeah, that's why you see all this below the x-axis one, these three, the answer are all deceleration, meaning they are all slowing down. Okay, so this section over here for acceleration time graph, don't need to read the gradient. Just check above or below the x-axis, then look at the number. Constant gradient, right? Then the value keep on constant. Then since you are accelerating means you are speeding up, so the velocity increases. So as long as you are accelerating, it means that you confirm speeding up. Because you all know, right? Acceleration means speeding up. You want to follow me and highlight it? Yeah, as long as you're accelerating means you're speeding up. Should be done highlighting by now. I move down. Okay, so then for the next part over here, it will be that as long as below the x-axis, it will be this. You can use another color highlighter. Yeah. So as long as you are deceleration, because negative acceleration. Yeah, negative acceleration is deceleration. I shortcut can because oops, I know space there. Yeah, negative acceleration is deceleration. Should be done highlighting and writing by now, right? I'm moving on in 5 seconds. 5, 4, 3, 2, 1. Okay, moving on. But anyways, no worries. Like if you find that today's lesson, you're like brain fried already, like don't understand what's going on, very confusing. No worries. This lesson is recorded. You can always watch the recording after that. Okay, so yes, after going through the content, let's try to answer worksheet question, exam question. Okay, so the question over here says that the diagram below shows the velocity time graph for toy car for the first 30 seconds of its journey. So they are asking you to describe the motion. So take note that for this topic, whenever they ask you to describe the motion, there is an answering technique that you need to take note of, which is you must always tell me in terms of either speed or velocity, depending on the graph, right? If they give you speed, then you write speed law. This time round, they give you velocity, so you write velocity instead, as well as acceleration or deceleration. So these are the answers that you need to have. Okay, so whenever motion, if you can write both, you try to write both speed and acceleration. Because if they were to give you displacement time graph, you can only tell the velocity, right? That's why if it's a displacement time graph, you don't write acceleration or you just write velocity will do. Have you written this in? Write it in. Okay, then next is take note. Just like I mentioned many times already, whenever they ask you to do sentence writing, please never ever write the word rate of. I wrote over here. Do not write the word rate of change of. You directly tell me what happened to the velocity, what happened to the displacement. What happened to the acceleration? Okay, don't write the word rate of change of. Okay, that is for math. Okay, so then let's answer section by section. So maybe we start off with the first section first. So to tell the velocity, you just directly read, right? So take note, okay, whenever it is a graph question, can you follow me and write it down? Whenever it's a graph question or a question that is a table, this applies to all 3 science, okay? Chem, bio, physics, all applicable. Whenever it's a graph or table question, you must always cite the values. That means I need to have this kind of numbers in your answer, like 27, -15, 12, 18 and stuff. Need to have all these values, okay, to show that you actually is applying and answering in context. If you don't have numbers, right, you will get 0 marks, okay? Write it in, very important. Okay, so then, yeah, so let's answer this question now. So usually whenever you have graph fashion, you need to chop them to different parts. So maybe we start off with the first section first. I think you can tell, right? First section will be this part here. Okay, so in this case, what happened to the velocity? So you can tell, right, from 0 become 20, that means the velocity increases. Then you have to be specific, increases from 0 to 20.0 meter per second. Okay. Then next, what happened to the acceleration? Can I have some answers? What happened to the acceleration here? So how to tell acceleration in a VT graph? You look at the gradient, right? Yes, thank you, Shannon. Yep, so the gradient is increasing. That's why the acceleration increases. Thank you, Faith, too. Yep, can you follow and write it down? Okay, moving on to the second section. So same thing, let's check the velocity, because first point always talk about velocity. So velocity this time around, it is constant, right? Yeah, so constant, and then same thing, state the value at 20.0 ms minus 1. Next, can you tell me what happened to the acceleration? What happened to the acceleration? The acceleration is 0, correct, because the gradient is 0, horizontal line. Good. Okay, then moving on to the next section. So next section is over here. So now I will randomly pick you all to answer my question, okay? Okay, so just now, I can't really remember where I stopped at. Okay, I think I stopped at Lily, right? Okay, then next, Justina, can you tell me what happened to the velocity? Then Jazel to tell me what happened to the acceleration. I prep you all first, So next up, can I get Joshua to tell me what happened to the velocity? And then Jody to tell me what happened to the acceleration. Can I have your answers, people? So, by the way, can you write down A equals or V equals? Can, because after a while, I get later, I get confused. Thanks. Okay, so Jazel says that A is 0. Then, wait. This one is 0. No, I think that was the previous answer, right? Sorry, I think I see wrongly. Okay, so Justina, what's the speed? Why no answer from Justina? Is Justina around? Then Jazel is A. Jazel, your answer, the 0 is for this question, is it? All right. Oh, no, okay, then can you tell me what's your new answer? Justina, what's your answer for V? Oh, okay, thanks. Justina says V decreases. Yes, very good. So again, same thing when you write your answer, decrease from 20 to 0. Good. Then for Jazel, what's your answer for acceleration? Constant. Very good. Okay, so moving on to the next part here for velocity. For Joshua, he says that it is increasing. Very good. This is the point that I was saying. From a speed of 0, it becomes a speed of -15. The math and physics opposite concept thing. Yeah, so for physics, -15 is bigger because you from at rest, now you are moving. Good. So you are increasing in speed, and then Joshua will answer very detailed. He even say in the opposite direction. Very good. That means your object is actually reversing, is moving in the opposite direction. Then for Jody, she said that the acceleration is constant. Good. Okay, so moving on to the next part will be this part over here. So can I get the V? Okay, right over here. Okay, so can I get Jia Yi to tell me what happened to the speed, and Isabel to tell me what happened to the acceleration for the orange color region? The rest of you, are you copying down the notes? Make sure you note down all these pointers, okay? Okay, so for Jiayi's and Isabel answer, Jiayi do velocity, Isabel do acceleration. How to interpret? Can tell, but if you don't know, you must tell me don't know, okay? Because if not, I'll just keep on wait. Later we cannot finish the lesson. By the way, the rest of you, you can give it a try to write out your own answer, because I won't be writing out the answer already. You practice it, because I already gave you like all the answers here. You just need to sub in all the values will do. Then same thing, I'll provide an answer key at the end of the lesson. You can then double check your answer. Okay, so for V over here, Jia Yi says that it's increasing. No, the speed is from -15 becomes 0, right? Just now we were saying, -15 is faster than 0. So that means you are coming to a stop. You are coming to rest. So Jia Yi, take note, the speed decreases instead. Then for the acceleration, Isabel says it's increasing. No, you also slowing down, right? You're coming to a stop. How can you be accelerating? Yeah, so that's why in this case, it is not accelerating, but this one is more of deceleration, but this is a increasing deceleration. Okay, so Isabel's answer should be increasing deceleration instead. Done. Okay, so I'll leave this question for you to do on your own. Remember to sub in all the values. So how do you phrase your answer? You just start your answer off with like from this timing to that timing. So maybe from t equals to 0 seconds to t equals to 7.0 seconds, comma, what happened? So you write down the velocity and the acceleration. Then after you are done, you do for the next timing. Yeah, so you always present your answer is like from which part to which part of the graph to let teacher know which section you are talking about. Okay, so your format is always the same. From t equals to, next one you can write as from t equals to 7 to t equals to 12. Yep, then you write in the V and the A. Okay, so this one I leave it to you to try out on your own at home. Yep, so that I can go through more concept. Okay, so for Ayana, yes, what's your question? Oh, it's above, okay. You are saying when did the thing pass the start point? In this case, to know when it passed the start point, you have to calculate the area under graph. Because start point is the distance, like the distance from the start point. So you have to calculate the area under graph of the top one versus the area under graph of the below one. Because the top one means the car going forward. The below one, you go and check my legend again. Below the x-axis means it is reversing. So it means you go forward and then you reverse. So you check if the area on top is bigger than below, that means the object, although he U-turn and reverse back, the object haven't passed the start point. But if the area for the negative, that means below x-axis, is super huge, bigger than the area above the x-axis, this means that when he reverse a lot. Yeah, then when he reverse a lot, because area under graph is displacement, if your reversing displacement is huge, that means you will pass the start point. Okay, can understand? Okay, that's good. Okay, so I shall move on. You all do this question on your own. And by now, you should have copied every single pointers over here, right? I shall clear the screen in 3 seconds. If you're not done your screenshot, 3, 2, 1. Okay, moving on. Okay, so moving on to the next page over here. So for graph convergence, just now I trained you all a lot already, right? Actually, yeah. So after you try out the practice, you can try on your own. So this one I leave it as I purposely included more questions so that you all can practice it. Yep. So you can give it a try to draw the displacement time graph and acceleration time graph. So for acceleration time graph, I think no problem because velocity time graph, you look at the gradient, you can tell the acceleration. But if it's the reverse, so if it's the reverse, how do you draw the displacement time graph? So for displacement time graph, you have to look at, okay, so let me give you, I guide you a little bit, okay? I just go through maybe the first few sections, the rest you do on your own. Okay, so now let's draw in the axis first for displacement time graph. Yeah, so can you follow me and draw in the axis now? By the way, because for this graph, I think you can tell the graph is like the above the x-axis is very huge. That means the moving forward displacement is more than the reversing displacement. That's why overall he is still in front of the start point. That means the displacement will be positive. Yep, so that's why I can safely draw a displacement time graph with only positive value. Slash meter, then time slash seconds. Okay, so how to do reverse? You don't look at gradient anymore. You just check this time round, what happened to the velocity? This time round, the velocity from 0 become 20, right? The velocity increase. Then remember in the displacement time graph, how to tell the velocity? The velocity is actually the gradient. And this time round, since we said that the velocity increase, that means when you draw the graph, you should draw increasing gradient. So you should draw a graph that curve go up. Okay, so take note, you go by, you check the velocity from 0 become 20, velocity increase, Then based on displacement time graph, the gradient is the velocity. And we deduce that velocity increase, that's why the gradient should increase. Next part, the velocity is constant. So same thing, the gradient, the velocity, which is the gradient, this time around, we say that it is constant. So how to draw constant gradient in math? You should draw a straight line. So that's why you draw a straight line, right? Because constant gradient. Then the next part over here, the velocity from 20 becomes 0. That means my velocity decreases, right? So that's why the next section is that for the velocity, this time around, which is the gradient, it decreases. So if it decreases, that means I must draw decreasing gradient. So decreasing gradient means I should curve it like that. Okay, decreasing gradient. Then the next section over here, this one is the velocity is from 0 become -15. Remember, the math versus physics is opposite. So it's from speed 0 at rest. Now while I'm driving very fast, I'm reversing very fast. So that means your speed is increasing. You actually labeled in the previous question, so it's the same graph. Yep. So that's why in this case, the next section is that for a displacement time graph, speed is the gradient, right? And the gradient is increasing. But take note, this time round, you are reversing. So if you are reversing means you must go back to the start point, right? That means my graph, I should try to go back to the x-axis, because once I reach the x-axis, it is the start point. That's why I should draw increasing gradient, go down. So that's why increasing gradient go down, it will be like that. You see, the gradient is increasing, and I'm trying to reverse, go back nearer to my x-axis, which is 0 displacement, which is my start point. So you are asking about the orange line. Is it straight? Why isn't it straight and not curved? Because this time round your velocity is increasing. So if your speed is increasing, that means your gradient must increase. What? So if your line is straight, that means you're saying it's constant speed. So if this line is straight line, then it will be the same as green one. Right? That means it must be horizontal line. Right? Because these two sections is totally different. It can't possibly be the same one. Okay, Ayana? Okay, so then continue on to the last section over here. Oh, in the end, I went through everything. I still thought of like skipping it. Okay, so then the last section over here, the speed from super fast moving, reversing, suddenly I come to a stop. That means I am slowing down, right? I come to a stop. But then this is negative. Negative means I am still pressing the reverse gear. So I'm like driving in the reverse direction. So that's why in this case, I'm still trying to reverse. That means I'm trying to go back to the start point. That's why my line should go down, and then my gradient should be decreasing gradient. So my line should go down, but with decreasing gradient. So that means my graph should be something like that. Decreasing gradient, and I try to go down nearer to the start point. So this is how you deduce for displacement time graph. The acceleration time graph, I leave it to you. Okay, so we shall move on. Oh no, I'm like far from finishing. I haven't even started on dynamics yet. Okay, I think we need to move on. So I shall move on. Okay, if you still not done, maybe you want to take a screenshot instead. I'm moving on in 5 seconds. 5, 4, 3, 2, 1. Okay, moving on. If your graph cut through the x-axis, that means you reach the start point already. And then if you go overshot and go underneath, that means you are before the start point. Because if you refer back to my notes, the legend again, then over here, once you are below the x-axis, that means you are at the negative side. That means you are even in front of the start point, like at the earlier stage before the start point. So that means once you touch this 0 displacement, that means you reach the start point. So Zaria can understand? Okay, so moving on to the next section here on free fall. Yes, we finally reached the 3rd section of kinematics. Okay, so need to know that the graph will look different in the presence and absence of air resistance. So in the absence of air resistance, yeah, there will be constant acceleration. Yeah, so this is a case where I think your teacher should have shown you all this video about the world's largest vacuum chamber. Yeah, where the bowling ball and the feather actually drop down at the same speed. Yeah, when there is like all of the air being like sucked away, like when it's a vacuum. Yeah, so since they fall down at the same pace, yeah, so this shows that the acceleration is constant. So how come is that so? Like, how come when don't have any like particles, like no air, when there is no air resistance, when it's a vacuum, how come so heavy bowling ball versus a light feather can drop down at the same speed? Is because if you look at the formula for speed, speed only involves distance and time. There is no mass in the formula for speed. So if you're thinking about mass affecting speed, that is more of mass affecting kinetic energy, not affecting speed. Because kinetic energy has the formula of half mv squared. So m is only involved in kinetic energy, not the speed. Okay? Yep, so then mass will only affect the graph only in the presence of air resistance. Yep, so because for in the presence of air resistance, you know there's this like terminal velocity thing, right? Yeah, so to reach terminal velocity, your weight had to be equal to the air resistance. Yeah, so that means in other words, for heavier object, the W value is very huge. That means your air resistance value should be very huge. Yeah, that's why your velocity should be bigger for heavier objects. Yep, then so the explanation like what I just mentioned is over here. Okay, so let's take a look at common graph for like this kind of examples. So for a ball thrown upwards into the air and then fall back into the hands, do you all know how to draw the displacement time graph? So anyone to like help to draw it? I'm not going to appoint anyone. Like by chance, anyone know how to draw it? Got 4 graphs over here. Can I get like volunteers to draw for all 4 for me? Do you all know how to draw? So I give you the velocity time graph. You draw for me the displacement and acceleration time graph. So how to draw? Can you draw it on my screen? People, quick, you volunteer, then I can move on to dynamics. If not like that, I cannot cover much topics though. Yeah. For me, is I don't want to rush through because if I chiong and teach very fast, then later you all don't understand. I think pointless lah. So I rather like go slow, you all can understand. Yeah, and then like maybe cover less, no choice. But at least you understand, right? Yeah. So sad. No one want to volunteer, no one to answer me. Oh, thanks, Rachel. Okay, so for Rachel's drawing, she feel that it's horizontal line, but your ball go up and come down. Then your displacement will change, right? Because you from the start point, you go away, then you come back. So yeah, so Ayana's answer is then correct. Yep, so it should be this line over here. Yep, so can you follow and draw it in? Yeah, so you go up, then you come down, right? That's why the displacement is go up and come back to your hands. So if your hand is the start point, that means you must come back to a displacement of 0. Then for this one over here, this one, you look at the gradient. Gradient is constant throughout, right? Then constant throughout? Yes, very good. So this is the correct answer. Oh, wait. Wrong. Because this one, if you look at the gradient, this is a negative gradient, right? So if it's negative and constant, you should draw the constant line at the negative region instead. Yeah, so actually this line here, let me shift it down. Oops. Oh, you removed it now. Okay, can then never mind. Then I draw it. I wanted to like drag your line downwards. Yeah, so the line should be below instead. Okay. So there's a ray is asking, why is it not curved for the first displacement? Velocity decrease. Oh yeah, actually it should be a curved line. Good point. Yep, it should be a curved line. Okay, come, let's change it. So it should be curved line. Yeah, because the speed changes, right? So your gradient must change. Yeah, because your velocity decreases. So that's why the gradient should decrease. Yep. Oh no, I also careless mistake. I draw a straight line. So later when I send you the answer key, be careful. This is then the correct version. Yeah, because it should be a curved line. I draw a straight line. Oops. Okay, then the below 2, no one to volunteer, is it? These 2. Okay, I go through since you don't want to draw. Oh, thank you, Runa. Okay, so for this one over here is above the ground. So that means you are at a certain meter from the start point, right? So that means in this case, you should be releasing from the top. So actually you should start from the top, then you come down. And since the speed is increasing, speed is actually the gradient, right? The gradient increases. Yep, so that's why in this case, the gradient increases. So it should be from on top, increasing gradient. So it should become steeper. Right, increasing gradient. Then after that, it bounce. Bounce means go up, right? Then when it goes up, what happened to your speed? Your speed decreases. So that means your speed, which is your gradient, it decreases. Yep, so that means your gradient should be becoming gentler. So it become like that. Oops, it should be the same height because it cannot go higher than your start point. Yeah, maximum is same height. Make sure you draw it in. Okay, then moving on to the right side here. Very good. Yep, this is the correct answer. Yep, because this is a positive gradient. So it's positive acceleration. So you should draw the line on top. Okay. Done. You should be done noting down by now, right? I'm moving on in 3 seconds. Okay, ready? If not, you screenshot. Ready? 3, 2, 1. Okay, moving on. Okay, so wait, XT is asking for the ball bouncing off the floor. The displacement graph is the opposite one as on top. You mean these two directly opposite? Not exactly the same because you see the speed is different. This one, the speed is slowing down, but this is the speed is becoming faster. Because when you go up, you're going against gravity. But when you're coming down, it is following gravity. Okay. Okay, so I shall move on. Done, right? Okay, so moving on to the next part here. Yep, so same thing. How do you all draw the acceleration time graph? By the way, take note, for the answer key for this page, you follow what I went through over here. Okay, don't follow my answer key. I realized my answer key, I forget to include the curved lines. Yeah, so my answer key a bit inaccurate. So how anyone knows how to draw for this graph over here? So in this case, this time around your acceleration, do you realize it's decreasing? Because gradient of a velocity time graph give you the acceleration, right? It's decreasing. And then it decrease until reach 0. So by right, actually, it should be, it's a downward line, correct, Rachel? Yep. So it's a downward line until it becomes 0. Okay, let me just draw it. Downward line and then become 0. Yep, for this part. Then, okay, I think we just stop at this part will do. Okay, so we stop at this part. Done. Let's move on. Okay, so should be done by now. Okay, so then next is another common kind of question that they will ask is like, again, no motion. Yeah, but this time around, whenever they say that you need to explain, take note, it's not describe. Just now describe, you just tell me, the velocity and the acceleration, remember the answering skill? Yeah, so it's the V and the A. But once they ask you to explain means you must tell me all the forces. Yeah, so that's why you realize the answers will include like air resistance, resultant force, weight. Yeah, that will be the answer. So this is a possible kind of question that will come out also. You can give it a try and fill in the blanks on your own. This is a very typical textbook kind of question, which you can find from your notes. Yeah, so this one, you should know how to fill in. I leave it to you, okay? So mainly the blanks to fill in is like increasing, decreasing. You try on your own, then you can check with the answer key that I'll be providing. Okay, so moving on, should be done writing the top left stuff over here, right? Moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so over here, there is a question over here, which is a little bit difficult. So let's go through it. So they said that a kayaker can row at 2 meters per second in still water. He challenges himself by rowing upstream in a river where the water flows at 1.2 meters per second. So they show you, the water flow at this way. Then after that, he's in the river, then he can row. No, he row upstream. But that means he's rowing against. Okay, so upstream means you are rowing against the river flow. Yeah, so that means the person is rowing this way. So now they are asking you to calculate the time taken. So this is easy, right? Time is based on distance, speed, time formula. It will be distance over speed, correct? So now can you try it out and give it a try, see whether you can solve it on your own? Part A is still not difficult. It is part B onwards that is tougher. You try. I'll review the answer in a short while. Okay, so should be more or less done by now. So the answer will be this. 1.25. I hope you can get it right. Okay, so moving on to part B. They say that the kayaker now decides to row across a river which is 240-meter width to the opposite side in the shortest possible distance. If you want to row the shortest possible distance, can someone draw on my screen? Which way when you row is the shortest possible distance? What thing? 1, 2, 5. You mean I press calculator wrongly, is it? 1, 2, 5. Oops, that means I pressed calculator wrongly. Okay, thanks for identifying. Okay, so sorry, and then my answer key will be wrong also. So y'all follow this. I pressed wrongly, right? Okay, because 2 of you say that I write wrongly. Okay, then that means I pressed calculator wrongly. Okay, thanks for highlighting. Okay, then 1, 2, 5. So my answer key is wrong. Be careful. I write 1.25. Oops. Okay, so yeah, so can someone draw it on my screen? What is the shortest distance that you can row to get to the opposite side of the river? So how to row the shortest distance? So shortest distance, you know, obviously it will be across, right? Yep. So this one is actually like the resultant. But you need to know that when you row, because of the water flowing in a certain direction, if I row forward, you won't possibly be moving forward, right? Because if you row forward, in the end, the water will just push you. Then in the end, you move like that. Yeah, so how can I row such that in the end, my resultant, it will be this direction. So what is the direction that the kayaker should row? Anyone can draw it on my screen? So water flow this way. But in the end, I want my ending direction to be this way. So when I paddle that time, how should I paddle? So if you paddle like the red and the black color direction, then the water also flows same direction as you. Then wouldn't you row even further away? Then your distance will be longer, right? Because this question, they want it to be shortest distance. Yes, correct. So like what Caleb have drawn or Ayana have drawn, you must row in the opposite direction. So only when you row in this opposite direction, then with the water pushing you, Caleb, can you remain your answer there? Because it's correct. Yeah, I want your answer. Thanks. Yep. So in this case, yeah, we want you to row in the opposite direction. So then with the water push, like the blue color one, yeah, your resultant will be the shortest distance. Okay. Yep. So actually for this question, you need to use Pythagoras. Okay. So for B part 1, I leave it to you to do on your own. Can you draw in a triangle so that you know how to solve it later? For B part 1. Okay, so I shall move on. Should be done copying by now. I'm moving on in 5 seconds. 5, 4, 3, 2, 1. Okay, moving on. Okay, so then next is, yep, so this is the direction. Then next is the time. So for the time that the kayaker will take to row, yep, it will be, you got the speed, right? Then for the distance, do you have the distance? Yep. You have the, yeah, you have the distance. Then you have the, sorry, my brain suddenly freeze a while. Give me a moment. Just now we were saying that we use Pythagoras to state all the direction. Oh, sorry, the direction, I haven't finished yet. Yeah, so direction actually is that you have to include the angle. Yeah, so you must measure what's the angle, then go and find the angle. So that's the direction. Okay, so just now got the red color line there, right? You must go and find what's the angle. So the angle that you roll. So that is the angle. Yep, then for time, you just make use of like the distance value given above and the speed value. You should be able to find it on your own. Sorry, I had to move on because no time. Okay, so next scenario is that they don't want shortest distance, but they want shortest time. That means I want to reach the opposite side the fastest. So to reach the opposite side the fastest is that you should make use of the water current, right, to help push you. So that means you roll plus the river push you, you can reach very fast. Yep, so now for the diagram over here, can someone draw it for me? Which direction do you think you should row? Then with the help of the water flow, you can go to the opposite side very fast. So do you have any idea? This one I would say is more of like the end resultant. Yep, so with the water flowing, actually the way you row, it should be, this time around, you should actually roll this way instead. Because when you roll this way, then when the water push you this way, then this will be the resultant. So do you realize, like, if it's like a Pythagoras, is like C squared is A squared plus B squared. So that means your speed plus the water speed give you your resultant speed. Yeah, so actually you should be rowing vertically instead. Then with the water pushing you, this will be your resultant faster speed. Okay, so can you draw this in now? There's like a lot of space, right? Just now you draw on the right, maybe you can draw on the left now. Yep, so this will be how you deduce the fastest speed. Okay, so should be done drawing, right? Because it's just 3 simple arrows, so I shall move on. Okay, so moving on to the next one is a MCQ. Yep, so can you all give it a try now? Yep, this MCQ, what do you think is the answer? I'll review the answer in a short while after you have tried out. Given an AT graph, what is the highest speed? Once you finish this MCQ, can you click the raise hand button to let me know? Once more than half of you complete this MCQ, I will review the answer. Okay, since more than half of you have completed, so I will review the answer now. The correct answer is C. Surprise! Do you get it right? I think a lot of you got it wrong. Okay, so why is the answer C? The reason is because you realize as long as you are above the x-axis, you are accelerating, right? This part is accelerating. This part is still accelerating. Even until this part is still accelerating. It is only when you reach here, then you stop accelerating. So that means you're accelerating non-stop throughout the whole orange color region. Then only when you pass this green color spot, only when you are here, then you are decelerating. So that means you accelerate until green one, then you change to deceleration. That means your higher speed should be right before you decelerate. That's why the answer is C. Okay. Yep. Done. Okay, so for the next section here, maybe I have a pause here first. Okay, so anyways, just wanted to also share with you all that so far I've been teaching all this while. You see whether do you think if the lesson is beneficial for you? Yep. So actually I'm at this tuition center called OVERMUGGED. Yep. So they are actually having some early bird packages if you are interested to sign up for tuition. Yep. So these are the subjects available. Yeah. So for IP there is actually Chem, Physics, E-Math, and A-Math. Yep. So then for the location wise, these are the locations. So if you are interested to sign up for any tuition, you can actually indicate the location that you prefer as well as the time slot. So all these time slots will be available in the sign up page. Then you try to select as many time slots as you can so that it's easier for us to arrange the lesson timing. Yeah, so if you are interested to sign up, you just scan this QR code, then it will bring you to the sign up page. Okay, so there are benefits if you would like to sign up earlier. So if you were to sign up now, that means until 30th September, we will be actually providing you 3 subject notes. So that means it will be 1 subject that is the one that you sign up, plus 2 other subjects of your choice. Yeah, so all these notes will be given to you. It will be topics from year 3 to year 4. Yeah, as well as when we are planning for the lesson timing, we will actually give you priority. Yeah, and then once you sign up, then I will immediately send you my notes. So you see, today you receive my scale vector drawing, the dynamics and kinematics, right? Yeah, so I'll give you my remaining notes, yeah, to prep you for your Sec 3 end of year exam. Yeah, so this is if you were to sign up soon, yeah, now. Yeah, then if you were to be a bit hesitant, maybe thinking, maybe I'll wait for my result come out first, then I decide, can. Yep, so that will be sign up for until 31st October, which is after your result is out. So that's when you can, there will be another round of free trial class. Yeah, so if you like this kind of free lessons, just continue to sign up, as in make sure you go and join the OVERMUGGED Telegram. Is the O-level channel, the IP channel not up yet. Yeah, so you just join the O-level channel. So that's when they will also announce there will be another round of free lesson, which is in November. Yep, so yeah, so this one is you can just attend, even if you don't want to join our tuition here, or maybe you have your own tuition or anything. Yeah, you can still attend the free class. Yeah, so it's free for all to join. But by then, the notes that you receive, it will be only 2 subjects. The subject you join plus 1 other subject. Yeah, then for the lesson day and time, it has to depend on what the previous batch of students who have signed up. Yeah. Then there's also the normal intake. That means maybe when year 4 school start, you realize, oh, you are struggling in certain topic that time, then you want to sign up. Yes, can also. But by then, it will depend on whether the class, whether still got available slots or not. Yeah. So the pricing for the tuition are over here. Okay, wait, I haven't given the answer key yet, don't leave yet. Okay, so then, so more details, you can actually check out the website. So for the lesson style, we will be having two kinds, physical versus online. So that means you can go to the physical classroom, or you want to continue to attend via Zoom, also can. Okay, so right now, because for this free lesson here, this event, there is actually a freebies to be won. Yeah, I don't know whether you all got pay notice to the advertisement that OVERMUGGED has been promoting. So right now, I will switch over to Kahoot first so that we can actually find out who is the winner. Then at least I can give away the prize. Okay. So so can you all go into Kahoot now? The answer key will be provided at the end of the Kahoot. But if you find that because I know I overrun, so if you are unable to stay back, you can leave like now. But I will actually after the Kahoot, I will do a quick run through of like my dynamics notes. So if like you find that you need help in dynamics, okay, maybe let me mute it first. Okay, yeah. So can you all start to join this Kahoot? Yeah. So is that when you are so after this Kahoot, after I give away the prize, then I'll give you all the answer key. Then after I give the answer key already, I will also briefly go through my dynamics note. So if you want to like receive more help on dynamics, you can stay back a while lah. So I aim to finish by 10 p.m. the latest. So I'll at least run through finish all my notes. So if any of you do not able to continue to stay on, you can actually join the OVERMUGGED O-level channel on Telegram. Then in there, they will actually post the recorded lesson link within the next few days of the lesson. So from the recorded lesson, from there, you will be able to get access to the answer key. Then there will also be a link in the, because it will be a YouTube video. So from the YouTube video, you can actually see the answer key link also. So you can download from there if you really need to leave now. But I will feel that if you don't have anything on, why not just continue to stay on? Take it as more practice. Why not, right? Since exam is coming. So so for those of you who really cannot stay, then you can leave already. So you can go off already. Bye-bye. Then once the rest of you join the Kahoot, I will start the game soon. Oh, no problem, in. Anyone still trying to join? If not, I'm going to click start already. If anyone still want to join, maybe shout out, wait, then maybe I hold on first. Oh yeah, by the way, what is the prize for the winner of this Kahoot? It will be the notes that you can use it for your Sec 3 EOY revision. So that means it's the remaining chapters because I only give you 3 chapters, right? So the remaining chapters I'll be giving to the winner only, the top scorer. But even if you not in the top few position, I would say that just continue practice the MCQ lah. Take it as practice law. Okay, I think I shall start now. So as mentioned, so you'll get to receive the notes. Okay, so let's begin. I make this Kahoot very fair. Even if your physics not strong, you got also teaching the IP chemistry on next Friday at the same time. So I'm teaching science. So there's a lot of answers. So try to make it fair, even your physics not good, you see, can still score one. So this one, were you paying attention just now? Question. Not bad. Is Toa Payoh, Bukit Timah, Hougang, and Jurong East. This one you need to slide. You need to arrange them in. Oh, okay. You need to slide to tell me what's the answer. So you calculate first. You press calculator. I give you a lot of time. Then you slide the correct answer. Must click submit. Okay. More seconds. So the answer is 2. So for every, wait, what's the answer? Oh, so cute one. They will slide here and there. Okay, the answer is 6. Okay. Yeah, so you have to use the average speed formula. Yep, so if you were to refer back to my notes, let me just click it out and show it to you how to get the answer for this. Let me see, where's my arrow up? Okay, so referring to the first page of my kinematics notes, that average speed, it will be total distance divided by total time. Yep, so you have to use the, oh wait, you can't find the distance. Okay, that means, sorry, in that case, that means you are supposed to be using which formula? Sorry, short-term memory. This is average speed. Okay, so for average speed, you should be using one of the formula here. Sorry, my brain a bit freeze for a moment. Yep, so that's how you get the answer. Moving on. Or you can draw the graph just now for that question. You can draw out the graph, then you find the area answer. Also can. Yeah, so this one is the, yep. So as you roll down, yep, as you roll down, it's like gravity pull you, so your speed will increase, right? Yep, so that's why your gradient of the displacement time graph should increase. Yep, that's why it should increase. Then later, constant speed, that's why constant gradient. Then this is like going up, so it's like going against gravity. So you're slowing down. So it's decreasing speed. So it should be decreasing gradient. Yep, so that's the answer. Oh no. So as you roll down, because the, wait, did I write the answer wrong? Equidistance. Wait, by right, when you roll down, because of gravity, it should be faster and faster. Oh no, but then the thing is that the circumference is fixed, ma. So even though you're faster or slower, they will still dot in the same frequency, right? Yeah, so this is the correct answer. Yeah, so it should be the same. Yep, trick question. Got a few correct answers. You can look at the picture for the hints. Yeah. I worked at 2 tuition centers before. Yeah, so previously I also got do I was also at like MOE school doing really teaching too. So I've been teaching for many years already, more than 10 years. Yeah. The OVERMUGGED will be the 3rd tuition center that I'm at. Yeah. You can check the catalog. Good. Majority correct. This one you have to slide up and down. Yeah, to rearrange the answer. You have a lot of time, you can slowly think and read. Okay, yep. So, okay lah, majority got it correct. That's good. This one just revise the notes lah. It's a very typical textbook kind of question. Okay, so continue on. This is the second last question. Very different, not the usual distance, speed, acceleration, graph conversion related to force. So how does force link to speed? We can use the formula F equals ma, right? So what happened to A? Then what happened to the speed? Yep, so in this case, it will be this line over here, because when you have increasing force, it means increasing acceleration, right? So that's why for a velocity time graph, gradient tell you the acceleration. So the acceleration, the gradient should be increasing. Then over here, if the force is constant, means the acceleration is constant. So that's why gradient, which is the acceleration, it should be constant. Yeah, so this kind of graph can come out also, right? Yeah, not always the norm kind. Yeah. Okay, so moving on to the last question for today to decide the winner for today. Yep, so this is the one you can just check the catalog for the answers. Okay, so let's see the results. Congrats to Caleb. Not bad, not bad. But it's Cheng Yu, is it? So the top scorer is Renee. Yes, congrats to Renee. Okay, so for the explanation just now for the winner, I'll be sending you the notes. Okay, so maybe can Renee later you stay back a little while so that I can arrange with you on sending you this prize. Okay. Yep, so done for the Kahoot. Okay, so now I'll be reviewing the answer key for today's lesson. Okay, so hold on, where's my paper? Okay, so yeah, so for the answer key, let me scroll all the way to the back here. No, overshot. Hold on. This one don't have the, oh, not this one. Okay, sorry. It is the other one. Sorry, I'm trying to find like my QR code that I've attached that has the answer key. It's over here. Yeah, it's over here. Okay, yep. So you can scan for the QR code to get the answer key. Sorry, I changed the speed a short while. Okay, can. Yep. So for those of you who are unable to like scan or somehow unable to get the answer, I will be sending the answer key link. Is my answer key link. Yeah, I'll send the answer key link into the Zoom chat over here also. Yep. So you can also download it from the Zoom chat. Okay. Yep. So make sure you download it. I'm moving on already. I should be done clicking the Zoom link or scanning, right? I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so right now I'll be going to go through briefly my dynamics notes. Yeah. Where's my dynamics notes? It's over here. Yep. Okay, so for dynamics notes, generally, the first page, I think this one you all should know very basic stuff like SI unit, then how to draw the different forces. This one you should know it. So this one I'm going to move on. So for the Newton's 3 law, all this you just study on your own. I think I want to go through like the key points, like things that usually most students get it wrong, the difficult stuff that maybe you all won't know. Okay, so I want to go through this example over here, this question here. Yep, so they said that a box of mass 1.5 kg is being put horizontally from rest across the rough surface by a constant 16 Newton force. Given that the box reaches a speed of 2 meters per second after moving 1.0 meter, what is the constant frictional force acting on the box? Yep, so why I want to go through this question is because usually for forces FR equals MA kind of formula kind of question, there is always a standard template. Once you follow that template, you will be able to get the correct answer. Yep. So usually for this kind of forces question, first step, you always write now what direction it is. Because force is a vector quantity, there is a direction. Yeah. So taking forward direction as positive, And sometimes if you can see the box, if they move right, then you say taking rightwards as positive, comma. So the way to solve it is you use this template, which is FR. On the right side, you fill in based on like the free body diagram. I write down shortcut again, FBD, free body diagram. Yep, so usually like for this question here, if we were to draw it, yeah, you can see that they actually push across a rough surface by a constant force of 16 Newton. And then since they say it's rough means there will be friction. So that means for the free body diagram over here, it will be the forward force minus the friction. Then below, you always follow a formula, which is MA. So the template that you always need to follow whenever you have dynamics question is this. Yeah, you always base on this, which is this L-shaped thing over here. So once you follow this template, right, usually all kinds of dynamics question, usually you will be able to solve it out. Yep, so now let's sub in all the values. So for the forward force, you know it, right? It is 16 Newton. Then for the frictional force, how to know what is the frictional force? You are supposed to calculate, right? Calculate the constant frictional force. So I will just write in as friction. Okay, then continue to sub in M and A. M, we know it, right? M is 1.5. Then A, what's the acceleration? So for the acceleration, they say that from rest, they reach a speed of 2. So that means in this case, yeah, to know the acceleration, that means this time around we need to draw the graph. Yeah, and then since they say that they are, yeah, they reach a speed of 2, so that means now you just draw in the graph law. So in this case, the highest speed you will reach is 2.0. Then they tell you that this is moving 1 meter. So that means for a VT graph, how can you tell the distance traveled? It will be the area under graph. Yeah, so that means this area under graph here is actually 1 meter. Yep, so next is how to find what is the T value. So you make use of area under graph. So area under graph is half times base times height. Yeah, so the height is 2. Then you know that the area under graph is 1 meter. And then that's how you can tell for the time. So then you do your math, very easy, right? Half times 2 is 1. That's why time is 1 second. So that's why for your acceleration, yep, you can use the acceleration formula already, which is the V minus U over T. So it's 2 minus 0 over 1. All right, V minus U over T. So that's the acceleration. Then you continue to copy the rest. Okay, so then yeah, then you just continue to solve also what in the end, what is the frictional force? Yep, then you just press calculator. By right, it should be 16 minus this one is 3. Then it should be 13. So then the frictional force is 13. Yeah, correct. Yeah, you're correct. I thought I careless again. Yeah, that's all. Okay. Okay, I take it that you should be almost done. I count down from 10 seconds. If you think you are still far from done, then maybe you want to do a screenshot instead. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, moving on. Okay, so moving on to the next part over here. All this is just notes content you can study on your own. Actually, you by right, you should know by now because your exam is nearing. Just wanted to highlight on this part on how to label the friction. So take note of free moving wheel versus engine powered wheel. Free moving means like there is no engine inside. They'll just roll or maybe roll down the slope on its own. But engine powered is like maybe there is a car engine or maybe a person pedaling, then the friction will be different direction. So how to deduce? So maybe is that for a free moving toy car. So maybe this time around, this toy car, you're assuming that it's like maybe on a slope, for example. Okay, but right, the car should be tilted lah. Yeah, so if your car is on a slope, you need to know that there's no engine force to make the car wheel to turn. So the thing is that your friction is the only force that causes the wheel to turn, right? Because if you don't have friction, like example, I put oil or I put a layer of ice, the wheel won't even turn, right? It will just, the car will just skid down without the wheel turning. Yeah, so that's why there is a need to have friction to turn the wheel. So in order for the car to slide downwards, your friction has to turn the wheel this way. That's why friction is pointing to the right. So take note, okay, that for free moving wheel is that although is like the so-called like the norm, that means if car go forward, friction opposes motion, also is backwards. But for engine power is different. So this time round, as you can tell, the bicycle is moving to the left. So in this case, for the power wheel, that means the part where you pedal it. So the thing is that because the force that you exert on the pedal, it forces the wheel to turn this direction, right? So that you can move forward. So then in this case, your force is in clockwise, anti-clockwise. Yeah, so it's in the anti-clockwise direction. That's why for your friction, it must always oppose the motion. That's why your friction, it should be towards the left. That's why you see this time around, the friction is to the left to oppose the force exerted by the pedal, okay, or by your foot. As compared to the front wheel, do you realize there is no force exerted because when you pedal it, you are not able to rotate the front wheel. So the front wheel, in order for the bicycle to move forward, your wheel have to turn in a direction which is this way, right? Towards the right. Yep, so in order to turn to the right, the only force present is friction. So that means in order for the wheel to turn, only friction can cause it to turn. So since I need to turn towards the right, that's why friction have to point to the right so that my wheel can turn to the right. Yeah, so the key difference is that because for the behind part, the forces present is that you have your feet, you know, your pedaling plus friction. That's why friction always want to oppose the motion of. But then for your free moving wheel, because there is no force, there's nothing for you to oppose. So friction, since friction is the only force present, friction has to make the wheel to turn so that you can drive the bicycle forward. Because if without friction, your wheel will just skid, right? It won't even rotate. Yeah, so how come the wheel can rotate is because of friction. That's why friction causes it to turn in that direction. So the friction direction is different for the two wheels. Yep, like that. Okay, so I shall move down. So next part over here, can you like quickly like give it a try so that I can explain to you like the answers over here? Then that will be all for today. So after you, oh wait, but I realize that there's 10 MCQ. Okay, that's a bit a lot. Okay, so maybe since I do not want to delay you further and it's already 10 PM, maybe you just give it a try first. Anyways, for the answer key, I've written down like the answers and then some of them I got the explanation. So you can actually just check the answer key from there. But maybe at least complete the question 1, 2, and 5. Yeah, can you do question 1, 2, and 5? Because this one, I think need a bit of a verbal explanation to you like live now. It's better. You do question 1, 2, and 5. So question 1 and 2 is the kind, you know, like MCQ asks you, which of the following statement is true or which of the following statement is incorrect? Then you know got A, B, C, D, and then you choose. Yep, so that's question 1 and 2 lah. And question 5. Then once you have finished question 1, 2, and 5, can you click the raise hand button? So the rest of the question that I'm not going through is that when you look at my answer key with the explanations inside, I believe you should be able to get the correct answer. Anyways, if you're like not sure like why the answer is like that, you can feel free to contact me. Yep, so let me put my phone number here. Yep, so that's my phone number in the Zoom chat. Yeah, so if you do not know any parts of like my worksheet, like why is it like that, like why the answer like that, yeah, you can feel free to take a photo of the question, then you ask me, then I'll answer you on WhatsApp or Telegram. So once more than half of you have completed, then I'll go through the answer already. So once you finish, remember to click the raise hand button. Desiree, I explain to you after class, okay? Yeah, just stay behind. Renee also must stay back so that I can arrange with you the price. Yeah. Okay, so since more than half of you have completed, so I shall go through the answer now. So this is true, this is false. I think the first one easy. The second one, the reason is because, right? Okay, they say that a negative resultant force always result in an object traveling in the negative direction. You imagine if I have a box moving forward first. Okay, so the box is moving forward originally. Then suddenly, wow, my friction plus maybe my air resistance blow until super hard. So the thing is that the object that is moving forward, due to inertia, it will take time for it to like slow down, then U-turn, right? Yeah, so that's why for an object with a negative resultant force, yeah, in the beginning, for the next few moments, actually by right, it should be just slowing down. Because when F equals to MA, if your F is negative, it just means that your A is negative. Negative acceleration is deceleration. So I can still moving in the positive direction, just that I'm slowing down. Yeah, so that's why this statement is false. Actually, this statement, statement number 2, I actually got it from one of my ORI students was sharing with me. Yeah, so this is from ORI, question 2. Okay, then for question number 5, this question is from OGS. So for this question, the answer will be 10 Newton. Why? The reason is because you imagine I have a rope, okay, I have a string. Then this time around, they say they pull 2 sides, right? I change the question a bit. If I say I only pull 1 side, do you think the string got tension or not? If I pull, my string will be like super loose and then just follow the flow, right? So that means if I only pull 1 side, the tension is actually 0. That's why you need to have the other side to hold the string taut. Yeah, so from 0, now I plus another 10. That's why now my tension is a plus 10 to get 10 Newton. That's why the answer is 10 Newton. Okay? Yep, done. That's all. Yep, so for the rest of the question, I will encourage you to complete them, take it as an extra practice for your physics exam. Yep, then you can refer to the answer key, and anything unsure, just feel free to contact me then. Yeah, then for those of you who are keen to sign up, yeah, you can sign up on the webpage with the QR code there. Yeah, then you can choose your timing of your preference. Yep, so then that will be all for today. So if anyone have any questions, you can stay back after class, then I can answer your question. Yep, so that's all for today. Yep, thanks for attending. Yeah, bye-bye.